Oh, yeah.
Hello.
Hello?
I think we're on.
Okay, we're on. Welcome back to day 4 of Homeschool Science. For those of you who are just joining us, I want to give you a quick introduction. My name is Dr. Erica, and I'm here with my kids, Georgia, who's a kindergartner, and Isabella, who's in 4th grade, and we're all doing it with you guys, so we get to have all the fun together. If you want me to give you a shout out to say hello, you can comment in right now, because I know some of you guys love hearing a little hello, and I'm curious if like Griffin or Raiden or Elliot or all of our other friends are out there. And while you guys are commenting in to say hello, a quick overview of the supplies you're going to need so you can run and go grab those if you need them. So we have a couple of ongoing projects that we've been doing, if you've been following us each day. So
Sadie says hi.
One of them
Joseph
is,
Rex.
hang on, we're going to get a list and then I'll say hi to everybody at once. One of them we're going to do is our eggs. So if you're doing the Osmosis Egg Experiment, you can grab that stuff. So you would need your eggs. And in addition, you would need water and salt water, or we're actually using corn syrup because I've never done that before and I think it's going to be really cool. So if you're doing that experiment, we are going to run through that real fast because it's a multi-day experiment. If you had started mummies with us, we're going to go over how to change our natron in the mummies because our mummified lemon and banana are getting kind of goopy. So we want to change the salt so that it still can draw more water out through that process called osmosis. But then our main project today is we are going to make shiny pennies and copper nails. And to do that, you're going to need a bunch of pennies. The duller, the better. And in fact, the older, the better. I find not stainless steel, sorry. You don't want to find stainless steel nails. You want to find regular steel nails, which is pretty much most of the nails out there. Most nails are either regular steel and then some are stainless. So you just want sort of like the old, grungy, or like nothing fancy, plain Jane nails, and those will work perfect for you. So you need pennies and you need nails. And then the other two things you need, some vinegar. Everybody needs about like a half a cup of vinegar per person. And then some salt. I know it's a strawberry, but for some reason we put our salt in a massive strawberry. It used to be confused for sugar for a lot, but not anymore.
Is there a substitute for salt that we can use?
There is not a substitute for salt. You definitely need the salt. And in fact, you can make the process work without the salt, but it's going to take you a decent amount of time without the salt. And we'll talk about why as we're doing it. All right. So who is joining us today?
So we have Amelia, Chloe, and Calvin.
Oh, good morning, Amelia, Chloe, and Calvin. Yay, I'm so glad you're joining us today.
We have the Berg.
Berg.
We have Sadie, our little niece.
They are different. Sadie! Oh, baby Sadie's on? Yay!
Yeah.
Hi, Sadie! Sadie's on!
We have Joseph
Sadie.
and Rex.
Oh, good morning.
Cobbie's there too.
Hi, Cobbie.
We have George and Henry are saying hi.
Oh, good morning, George and Henry. I like how I'm saying good morning. It's like not morning. It's technically still morning. I'm still good.
Anna and Clara are here.
Hello, Anna and Clara. How are you ladies today?
And we can't forget about Emmy.
Definitely not Emmy. Is this Emmy on Bainbridge?
And
I miss Emmy.
Kaya is here.
Hello, Kaya.
We have Raiden, and he's eating cake from Tuesday.
What? Raiden, you are like way too lucky. I hope, you know what, Raiden? If you're here and your brother could totally do this experiment if he's around too. He would be doing it.
May is here as well as classmate.
Hello, May. Say hi to May.
Hi, May.
I wonder if Lila and Millie are here too.
We have
We'll find
Ruby and Leif.
Hello, Ruby and Leif. We know them too. All right. Give me one more and then we'll get started.
I think
Is that what we got?
It. That's it. So Kaya's here.
Yes. All right.
Kaya.
Okay. So let's get started. So, and before we start, moms and dads.
Colin and Elsa and Lauren.
Oh, Colin and Elsa Lauren. Hello. How are you, my fabulous friends? Make sure that you subscribe, that you give us a thumbs up, and you get our notifications when we go live. So, and what I'm asking you girls to do is take your egg out and you can pour your dead vinegar into the green bowl. So we're going to take our eggs out.
It's so cool. It's like clear.
It's like clear. I know. It's yellowish because you can see the yolk in there.
Yeah.
You could hold it with your hands too
And
if you're
super
worried.
big. How do you squishy?
Like this.
Well,
Just
can I
pull it out.
how do you take
There
it?
you go. Just like that. Just be gentle.
It's like
Beautiful.
really weird.
All right. So now we are perfectly set up for this. because the girls have taken the shell off of the egg with that vinegar. And this that's around the egg right now is the membrane.
This is the yolk?
No, that's actually the membrane. So inside our eggs, we still have like all of the whites and the yolk that's in there. This is just a normal egg still. Probably wouldn't be very good to eat because what happened? We saw yesterday that it got bigger. Here, why don't you put your egg on this? So we are going to see about osmosis. And with osmosis, remember we learned that water always wants to go to wherever there's less water. It wants to try to equilibrate something. So inside our egg, we have a whole lot of proteins and fats, and we have some water. Georgia's going to put her egg in just plain water, and she can choose a food dye color she would like to put in. What color would you like your water to be? Plop it in.
Chicken splash.
Doop.
Well, no, like a video.
It bounces, and now it looks really big inside there with the optics of that
is
glass.
It actually that big?
No, it's not. If you look down, it's not as big. Pick a color for yours. You want me to hold it up? There is Georgia's egg, and she's going to pick a color.
What?
And I want you guys at home to think, where is there more water? Is there more water on the outside of the egg, or is there more water on the inside of the egg? So we can think if this water will go into the egg to make the egg bigger, or out of the egg to make the egg smaller.
Mama, is it going to go in the egg into that color?
We're going to find out, aren't we? Meanwhile, Isabella is going to plop her egg into corn syrup. And this is like really, really thick. But Isabella can press hers down. And Bella, if you would like to also choose a color. Ooh, it's floating in the corn syrup.
Are they supposed to take the shell out?
So if you've been doing the project with us since Monday, you would have put an egg and vinegar. And the vinegar eats away at the shell of the egg because the shell of the egg is basically baking soda. So you have sort of that fizzy reaction for a few days and it eats it away.
I really like blue, but I don't.
Go for it.
It's not going down.
It's not going down. That's okay.
Georgia, we can always do a different one.
We can always do a different color.
Which one do you like?
I like the blue.
Which one do you
Belly likes
want?
the orange. Belly wants orange. All right, put some orange in there.
I want blue.
And this project is about one more day. Tomorrow we can look at the results of our eggs together.
Is that enough?
That's probably totally enough. You could take your spoon and you can mix it up in there.
A little bit.
Okay, a little bit more. Georgia, would you like to mix yours up?
That was only one drip.
Only one drip. Look at that. All right, so we're going to see where our stuff goes. And I want you guys to think about where is the most water in both of these?
That was only one drip.
There's only one drip.
Belly's is not as good because with corn ale, and it looks better with only one drip in water.
I know. Isabella's is really thick. It means there's not much water in the outside of Isabella's. There might be more water inside the egg. We'll find out. So this is going to be our project to look at. We'll observe this one tomorrow. And if you're doing it at home, you're all set up to observe it tomorrow. There's your spoon. All right. So the other project that we have that's a long-term project is this guy.
I want it to form this color blue.
It is. Oh, you want the egg too? Well, be careful. Don't pop the egg. Be gentle with our eggs because they don't have a shell to protect them anymore. All right, so Isabella and Georgia started mummifying their projects on Monday, and you can see just how much water has gone in this because the salt is sort of clumping down.
Yes.
Oh, Georgia thinks she's seen it inside the egg already. Let's let it be for now, though. Okay. We're going to let that guy sit overnight. So we'll put these guys both up here. So what we're going to do to change the salt in our mummies, if you started a mummy, you need a new Ziploc bag. And what you'll do is you'll add your banana. The bananas are tricky. The bananas have a lot of water in them.
Do I have to bring it? Wait, but Mama, out. Do I have to bring Can I taste the salt?
No, you don't want to taste the salt. That's going to be kind of icky because, right, it's been hanging out with stuff for like 4 days. It should be fine because we talked about how the salt kills the bacteria. But in general, you always want to be on the safe side.
You hold it, it's like brown.
I know. Georgia's banana is brown. It's tiny. It's very small. And for the bananas, here's Georgia's. This used to be like a banana, and it's really, you might not be able to quite see it. I don't want to hold it because it's really smushy right now. So, but it's like, it's about this long. And it's pretty thin right now. It was like a normal whole banana, and now it's like really small if you look at it. So the salt is taking out all that water. And if you look at the salt around it, it's really moist salt, which is gross. So Bella, you're gonna fill up the Ziploc. That's okay. You can leave that for now.
I want to see.
We're not gonna weigh anything quite yet. We'll do that on Monday. But if you're finding that your salt is looking pretty wet, you're gonna want to just change the salt real fast.
It's black.
Okay, George's is black. And you can keep the old salt inside the Ziploc bag. And you can just throw that away.
Look, Mama, look.
So again, ooh, yeah. I would let it be. You can pour a little bit of salt over that, Georgia. So I want you to pour a bunch of salt in here. So our mix of Natron is just salt and baking soda. If you weren't here with us on the first day, and it's not too late. All right.
Putting some in.
All right. That's good.
Okay.
All right. So we'll just re-salt and zip it up.
It feels like snow.
Yeah.
Feel it.
It feels like snow. All right. Oh, we have a lot of salt that's on our table now. Okay. So those are our two projects that we have that are sort of ongoing for you guys.
It's like moldable now.
It is moldable. And that's because the salt has taken out so much water. Just put it right on in there.
I like it.
Zoop.
I'm going to fill a balloon with this and then make it a squishy toy.
Ooh, we're going to make a squishy toy later today, it sounds like. So let's make sure we don't throw those away. Those are our two old projects. Should we get started on our new project?
Yeah.
Oh, okay. George is not quite ready. But you don't have to do it with us if you don't want to. We are going to make copper nails.
Mine's way bigger than Belly's.
Yours?
Yeah, see?
Yeah, it does look bigger. Yeah, we're done with all those. So to make a copper nail, you take your nail and you just put copper on it like that. And we're done. We're done.
No.
No?
No.
You think there's more magic up my sleeve? It's true. This would be kind of boring. What we're first going to do is we have to get the copper for our nail. And what you'll do with that, you girls can each get a whole roll of pennies. And you're going to dump your whole roll of pennies into your cup. And as you dump them, you might notice there's some pennies that are like really dull. And there's some pennies that are really shiny. In fact, if you're at home looking around for pennies, the dull ones are better. And that's because the dull ones, I mean, they're still copper. Why do you guys think they're dull?
Because they're older.
Ooh, so what would them being older, why would that make them duller?
Because I'm pretty sure that I read in a book that if exposed to water, copper turns green.
Yes, Isabel's right. If we are exposed with water, copper does turn a greenish color over time. Yep. Ooh, we have one that has like a little bit of green, but I'm kind of noticing, I like that observation, Isabella.
I have a green one.
You got a green one? Ooh, perfect. No, keep it in there.
Mama,
we want to keep it in there.
I have one.
Yeah, we've got some. So we want to keep them all in there.
4.
But this dull penny, most of the dullness is not
5,
green.
6.
And it doesn't come from water.
7,
it comes from air. Let's not do all of the
8.
because people at home might not hear us. So this dullness comes from the air, and it comes because, like, let's pretend this is like my surface of copper on the table. And the copper is like totally happy. It's hanging out. It's doing its thing. It's pretty and shiny. Yep.
I have so much of the dull ones.
I know. We're going to keep them in your bowl.
Mama, look how good this is.
I see. We're going to keep them in your bowl. So I've got this beautiful shiny copper. It's like hanging out. They're all together. They're happy. And then there's this oxygen molecule that just happens to be in air. And it's like super negative.
Mama,
and it's like, oh,
look how
really need a friend. Hang on, Georgia. I really need a friend. And it's like, I'm going to go find a friend. And it goes over and it's like, you, taking you. And it like attaches itself to the copper. The copper's like, oh no. But it doesn't really have a choice. And so the copper gets oxidized into copper, and copper oxide is what it's called. And copper oxide is kind of sad because it's like, oh, I lost my shininess. That's too bad. So what we're going to do is we're going to bring back that copper sparkle first because we need to get our copper for our nails from somewhere. So to bring back our copper sparkle, you're going to need about a 1/2 cup of vinegar.
Wait, Mama, this one's from 1924.
Ooh, perfect. That's even better. If you have pennies from pre-1982, those ones are 95% copper. Pennies after that are actually mostly zinc. In fact, if you were to snip them in half, you would see like sort of like a steel-ish color, like a grayish color, and then it would have a copper coating. So new pennies only have like 2% copper. Old pennies have 95% copper. And perfect. You're going to put a half a cup in here. So put all your pennies in your bowl. Really important that I did not say earlier, your bowl cannot be metallic. So if you have a metal bowl right now, you want to go find a plastic or a glass bowl really fast before you do this, because you don't want a metal bowl. All right, Bellies, we have a quarter cup here. How many quarter cups do we need to put in a half a cup?
Why don't you, Mama?
We need 2. Perfect.
Why don't you?
It might be easier if we pour it.
Wait, what happens when,
Vinegar.
will you see the 1924?
Yes,
Still?
it's not going to eat away the whole penny. You're going to put 2 of these in. So here, you hold this. You're just going to take off that really dull surface, the copper that's sad because the oxygen came in and stole its luster.
1973s, and they look exactly the same.
All right.
But they look different from the other ones.
So we are going to. So we put vinegar in, a half a cup of vinegar so far. And if you do this and you don't have the salt, you would probably have to wait overnight to do it. So vinegar is an acid. Acids have a whole bunch of positive hydrogen atoms. It's bubbly because you put baking soda inside.
I did?
Yep. So it has all these positive hydrogen atoms that are going to go around and look for things to do. But we kind of want to make our acid stronger.
I don't want it to be bubbly.
Well, it will stop. Look, you can see that? And now it's not bubbly. So the way we can make it the stronger is with the salt. And what's going to happen is salt is sodium chloride, and these extra hydrogen ions, these positive guys that are hanging out inside the solution, they're going to mix with the chloride ions, and they're going to make hydrochloric acid. Very small amounts, so you do not need to worry about it being super dangerous, but it's just a little bit of a stronger acid to help our pennies. So you're going to put in 1 teaspoon, which for us is going to be 2 of those cups. And then you're going to put yours in 2 of those. And then we'll talk about what's happening, and you can mix it. If you have only a spoon, use a spoon. If you have something that's not metal, use something that's not metal to mix your stuff with. All right, Georgia, I put in a whole teaspoon. So this is a half of a teaspoon. I'm going to put in a whole teaspoon.
This one is.
We're going to make them super shiny.
This one's
that one's already shiny, I know. Would you like to put in your...
This is a dime.
Nope, that's a penny.
But
it looks cool, though.
Look how shiny this one is.
It's very shiny, and it's got an interesting person on the back. Will you put in a teaspoon of salt? And then you're going to mix it up. You put a teaspoon of salt in there. And what's happening now, as we're mixing it up, we have an acid, which has all those extra positive hydrogens, and they are like wandering around being like, what do we do? What do we do? I don't know what to do. And then they see the oxygen, and they're like, oh, oxygen is my best friend. And they try to tug on it, and the oxygen is like, no way, man. Like, I am staying here with my copper. And it's like, no, you're not. And it's like, I'm going to go get my friends. And you get 2 hydrogens that come over together. They buddy up, and they're like, we're yanking on you. And they pull that oxygen off, and the oxygen's like, oh. And the copper's like, yay! And the copper is nice and positively charged. It's going to go hang out in our solution.
Shiny.
I know, but we want to leave them in here.
No, but it's too shiny.
It's going to get shinier. That's what we're doing. We're shining them up. You should see the pennies shine as we're doing it, because those 2 hydrogen positive things are joining up. They're joining up as friends, and they're ripping that oxygen off. They're ripping that copper oxide off. So then the copper goes into the solution that we have.
Mama, look.
And what do you think the 2 hydrogens and the oxygen make?
Look.
Anybody know? You can comment. What do you think H2O makes?
Look.
Yeah, it's pretty. What does H2O make? Anybody have an idea? You probably have heard. Yes.
Oh.
So we are making water in here, and we are taking off. Have still
this is so shiny,
clear liquid.
It doesn't really look.
But
so
your pennies are getting shined up.
No, they're not.
They are. They're
Look
getting
at
there.
mine. Look at mine, Mama.
They're getting there, and you gotta wait for a few minutes.
What happened to this penny?
So if you have questions, now a great time. Hang on.
So much.
If you have questions, now is a great time to ask a question, because we gotta wait for a few minutes for all those hydrogens to gang up with another hydrogen to rip off all the oxygens. It might be like glue or something. I'm not sure. Yeah, if you want to check it out. Do you see that? Nope, she doesn't want you to see. I don't know why. It just looks like glue flakes. So, any questions?
I mean,
Anybody
I do have
questions
a
that they're
couple.
commenting? Yeah, we're cleaning this stuff up. Nice and good.
This one especially needs cleaning up.
Yes, so just keep mixing them.
Wait, Mom, I don't
Mix them all up.
Both got the right answer too.
Nice!
They
Good
do.
job! They figured out that 2 hydrogens and an oxygen make water. You want to leave your pennies in. Leave your pennies in as you stir.
What happens if they added more than a tablespoon or teaspoon of salt?
Nothing. I think it might actually make it stronger.
Ooh.
But we don't want to add so much salt. So you want the salt to be able to dissolve, hopefully. Yeah, I don't think anything should happen if you add too much salt.
Calvin asks, how do they join up?
Ooh, the hydrogens and the oxygens. So the hydrogens have electrons around them. They always have one positive electron. Hang on 1 second, answer the question. So, and the oxygen is always on the hunt for electrons. So oxygen's charge is -2, which means it doesn't feel whole unless it steals 2 electrons from somebody else. When it steals an electron, they actually have to hold hands for it to steal the electron. So hydrogen has 1 electron that can hold hands with. Oxygen has 2, which is why it sort of holds hands with 2 hydrogens. And then the reason why it pulls the oxygen out of the copper is just that the hydrogen is more alluring. It can pull a little better. And so the oxygen ends up saying, yes, you are a little bit better for me because you make me feel a little bit more complete. And then the copper, when it loses the oxygen, that copper oxide now has a +2 charge because it was doing the sharing thing with the oxygen, so this should be copper oxide, CuO. But then it lost 2, so it's positive, and this guy's negative, the oxygen was negative. So now we have sort of positively charged copper ions floating around in our thing.
Used to be so dirty, but now.
I know, some of these ones that were so dirty are now cleaning up.
Can I keep these pennies?
You can keep these pennies.
Because we made them.
Yes, and in fact, we have some other projects with these pennies too. Yeah.
I have a question from Fanny. I don't quite understand. She's asking if we can get the water out of there.
Ooh, can we get the water out of this? We can't because we are in a solution right now. So,
have the salt.
Okay, let me back up. We could. I think you actually probably have enough salt in there. But the water, when it gets made, goes straight into the solution. So you don't really see it. If you wanted to get all of the water out, what you could do is you could boil it and the water would turn into steam and it would leave all of like the sodium and the chloride and the copper and all of the acetic acid pieces from our vinegar in the pan. And then the water would kind of go off. So you can maybe create a contraption that would let you get the water. But you can't actually take the water that's interacting with the oxygen on the copper surface out.
Okay. Sonia asks, she doesn't have any steel nails. Is there something else she can use instead of a steel nail?
Ooh, anything steel, aluminum foil, I think will work. I think aluminum foil should work for you. The trick with aluminum foil is what we're going to do will also eat the aluminum foil at the same time. So the nice thing about the nails are they're kind of thick, so when it eats away at the nails, we don't notice. The aluminum foil, it might get thinner, so I would just plan on that it gets thinner. All right, let's see, how long have we waited? They're looking pretty good.
So Emmy was wondering, she might have missed it earlier, why are some clean and some of them are not?
Ah, yes, great question, Emmy. So some are clean because either they're newer or someone has cleaned them or someone has kept them in like a bag without oxygen. So the oxygen in our air that we breathe is always looking for stuff. So it's always looking for 2 friends or somebody to give it 2 electrons. And it interacts with a lot of stuff because of that. And it sees the copper surface and it goes on in and it just pulls some copper out and it forces it to be friends with it. And that copper oxide, instead of just straight copper, copper itself is shiny. It looks like a brand new penny. Copper oxide is really dull. It's brown, not shiny, not pretty.
This is not shiny.
That's not shiny. And this oxidation happens with everything. So everything around us is oxidizing.
Am I
all of this time. Yes, our cells use oxidation to survive. We rely on it for a lot of stuff. Sometimes it's good, sometimes it's bad. But like our cars rust because of oxidation. So that oxygen that's in the air likes to bind with so much stuff, and as it does, it pulls things out and makes new compounds. So instead of it being copper, it's then copper oxide, which is dull. is kind of a bummer for us when we look at it and we want it to be pretty.
James would like to know if we can use other stuff to clean pennies other than vinegar.
Other than vinegar, you could use another acid to clean the pennies. So any acid has those extra hydrogens that are going to go around and be really peppy and try to steal things away and grab the oxygen and make the water. You probably don't have a whole lot of strong acids in your house. So a lot of strong acids like sulfuric acid, hydrochloric acid, like actual strength acetic acid. Those are things you find in a lab where if it gets on your skin, it's going to like eat through your skin. So vinegar is a good safe bet. Some of them are done. So Georgia is saying some of them are done. What do you think, Belly? Are we getting there? So if you feel like some of them are done.
1979.
1979. Ooh, that's a great one because that one's got a lot of copper in it because it's pre-1982.
Mine had 1920.
So it's probably been about 5 minutes. Do you think it's been 5 minutes?
2018.
All right.
Wait, why are we gonna dump it?
No. Ooh, great question, Isabella. We are not going to dump it because what is in our solution right now? Anybody remember?
Vinegar.
We have vinegar. Yes. Salt. What else do we have in there?
I never said anything.
We have the water that got pulled off and created. We don't have air in there, but when the water got created from those oxygens, we pulled off copper. So there's actually copper in our liquid right now. If we pour it out, we can't put that copper on a nail. So you want to keep the liquid, but you can scoop your pennies out and put them on a towel. And if you have water close by, I would suggest you actually rinse half of your pennies and leave the other half unrinsed as another experiment. Okay. So girls, if you want to actually take half your pennies out, you can go take half your pennies and go wash them in the sink and then put them here to dry. And then the other ones you can just put on here. You just grab them with your hands. Here.
Citric acid?
Citric acid would work, yep.
That's half of them?
Sure. It doesn't really matter. Here, there you go. Go wash these guys.
Somebody has tried apple cider vinegar, but the pennies are still dirty and getting dirtier.
Did they use salt? Do you have salt in it? Salt's pretty important. I would imagine apple cider vinegar, it's pretty much the same thing because apple cider vinegar and white vinegar are both like 5 to 7% acetic acid.
The ones that are not nice.
Oh, we have a question. Do we have to use pennies? Can they use like dimes or quarters that have been...
Ooh, great question. We have to use pennies because we need the copper. And dimes and quarters and nickels don't have copper on them. Georgia, do you want to come around this side? So that we don't see the back of your head. It doesn't have to be exactly half. You just want some of them. You want to take some of them and rinse them. And then you want to take some of them and not rinse them because it's kind of an extra project. Just scoop it in your hand and then go over to the sink to wash it off. Yeah. There you go. Maybe cover your hands so we're not dripping everywhere.
What the heck?
Well, we care.
Nice. Now, if you find your pennies haven't gotten super shiny yet, that's okay. You can let it actually sit longer. The longer you sit, the more copper that will pull into that solution and the shinier those pennies will get.
Mama, can I take a super dirty one and just put it in and wait?
You totally can take a super dirty one and keep a super dirty one in there and just leave it in there for a while. That's totally fine. All right. So we've got we got our rinsed ones. So these ones are not rinsed.
Mama, look.
And these ones you'll put over here are rinsed.
One and look how pretty it is.
I know, it's so shiny. It's beautiful. So we want to take the rest of these out, and we're going to also put them on the towel.
So dirty.
If you want to leave the super dirty ones in there, you can.
Look.
And this is one of those projects you can also try it again. You can keep it. Yeah, we do have some dirty ones that are not working, but we can leave those ones in there because the more copper oxide that has formed on it, the deeper it can get. And the salt does help sort of drill into that surface and flake the copper off. That one is pretty. All right, so we've rinsed half and we've left the other half as is. In theory, you should see what's going to happen in like the next 10 minutes, but I've sort of found out in practice it sort of takes overnight-ish. So this might be a project for later, but we'll find out. So we're going to put these guys up here. I'm gonna put your guys up here, okay, Georgia? Or I guess you can leave yours like that. Now you need your nails. La.
We're still having trouble with the apple cider vinegar.
With the apple cider vinegar, we're still having trouble. And they added salt.
We added salt.
How much salt did we add? I'm curious. It might need more time, but it really should work with both.
We don't have a response yet.
Okay, we'll wait on that response. You need a steel nail that's not stainless steel. Why do we not want a stainless steel nail, do you guys think?
Wiping it works, so it was just dirty solution.
Oh, it was just dirty, beautiful.
Look at this.
So we have I'm curious why I wanted steel nails that are not stainless steel nails.
Can I dishwash?
Because it's stainless. What does that matter?
Can I dishwash the good ones?
Because you can't put anything on it because it's stainless.
Isabella's got it. If it's a stainless steel, it's actually been treated with, what is it? I think chromium that it's been treated with, so that when you try to pull things off of it, the chromium actually comes to the surface and interacts with whatever is there. So we don't want stainless. We want just plain old steel nails. And we're going to put a steel nail in. You girls can choose what kind of nail. We have two types of nails. We got one that's like, I don't know, it's got a thicker head and one skinny one. You guys can choose which one you want. And you're going to plop it in the solution that you did not get rid of. We're going to plop it in there. And we're going to hang out and wait for a little bit. Oh, this solution over here, Georgia.
Galvanized won't work, right?
Oh, what is galvanized? Galvanized is when we heat it and it's stronger, right?
Yeah.
When it's strength treated by heating. I mean, if that's all it is as the treatment is heat treatment, then galvanized would work. But I'm not 100% clear. I don't remember exactly what galvanized nails are. And if you've plopped it in, we're just going to hang out and wait for a little bit. So this is a great time for more questions. But let me tell you what's happening as we're waiting. So the vinegar and the salt that's in there, they used to be drilling on the surface of the copper penny and pulling off the copper and the oxygen and making the water. Now it's drilling on the surface of my steel, and it's making it like so that there's all of this zinc or iron atoms that are negatively charged. And
Getting all bubbles.
the negative charge, ooh, we're getting a little bubbles, awesome. The negative charge is what happens with negative and positive charges. Do they like each other or do they hate each other?
They hate each other.
Positive and negatives hate each other?
No, they like each other.
They like each other. A positive charge and a negative charge love each other. They're like so stoked to be together because the positive one is like too happy for it to be actually happy, and the negative one is like so sad. So the positive one gives it a little bit of a boost, and then everybody's like, we're at a good level. So what's happening is we're actually taking off some of the atoms that are on that nail, and we're making the nail negatively charged. But Isabella, what's in our solution?
Acid.
Acid and
Copper.
copper, and our copper was positively charged. So what's going to happen is the copper is going to be so excited to stop being all by its lonesome self, and it's going to go and find some of that negative charge on the nail, and it's going to bind together, and they're going to be so happy. And what we'll get as a result is a copper nail. And this is a nail that I did earlier this week as a test. I'll put a second nail up. It's going to be hard to see the coloring. How can we put a piece of paper? Does that help?
Mm-hmm.
So you can actually see that this one is very like a silvery colored and this one's a copper colored. But this takes a little while for this reaction to happen.
Tilt it backwards.
Tilted backwards like that. All right. And I'm actually not sure what will happen if we put pennies in there. I kind of imagine it might speed up the reaction just because you still have the copper in
You
there.
can see
Yeah, we're
stuff
bubbling in
coming
there.
no, you can see stuff coming off. Like
Of the penny?
no, there was like if it was over there, and when you hadn't put your finger in, there was like your finger. There was like little tornadoes coming off.
Ooh, yeah. So I'm really curious. And you won't really see the copper form on the nail until like in about 10 or 15 minutes, we can take those nails out and let them dry. And that's when you really see the difference. I personally found it hard to see the difference in the bowl. We have educational screen time after science, but soon. Soon. What other questions do we have while we wait for our nails to hang out? Anybody, do we have any other questions? No, not at the moment. All right.
Are we doing a Zoom session after this?
We are doing a Zoom session after this if you want to come hang out and have lunch. And in fact, I know I told a lot of people we would learn some Tinkercad. So if you're interested in that, I'm thinking I might do a little Tinkercad tutorial today while we eat lunch together. So if you're interested in learning about Tinkercad and how to do modeling in 3 dimensions, we can learn a little bit about that. If you want to do that, you would need a computer and you would need to log on to tinkercad.com. And it's free. I don't know if you have to have a login information or you can just design. You might, if you want to save it, you'll need to create some credentials. But that will be fun. So we'll make pencil toppers. If you're on Bainbridge Island and you come and create a pencil topper with us, I will be happy to print it for you. If you don't have a printer and you're not on Bainbridge Island, there's a lot of places that do. So you might look for your local library, which is probably closed, or your local makerspace, which is also probably closed. We might be out of luck for a little bit. You can go online and buy them and people will like print it for you. Although now that I'm thinking about that, might even be harder because right now people are 3D printing face masks for doctors and ventilators for doctors and all this cool stuff. So a lot of 3D printers right now, like sort of the people who commercialize that and you can buy from them are actually saving the world at this moment. So they might not be the best, but I might, if it's small and it's mailable, I could probably print it for you and just mail it for you. So you could just send it our way. We're just gonna make little pencil toppers in that class. So that's after if you want to eat lunch with us today, or I guess maybe if it's later for a lot of you guys. Just hang out, it's probably post lunch for some of you guys.
So is there any takeaways that we want people to
So
know about?
Takeaways from this guy is chemistry is awesome. We took a copper off of a penny and we're going to plate it on a nail. And it just takes some time. We're seeing a lot of bubbles in ours. I didn't see that when I did it, but I did use less salt. So I'm curious.
Used like 5 teaspoons.
Because these bubbles are probably,
I only used 2.
well, they're probably carbon dioxide bubbles.
I only used 2 spoons.
2 spoonfuls. Awesome. So what we'll do is we'll probably leave your nails in there for maybe another 5-10 minutes and then pull them out and you can, don't rinse them, just put them on something to dry. And as it's drying, you'll see that copper coming out onto it. And then in the meantime, we'll switch over to Zoom. Last quick messages. Don't forget to subscribe to get our notifications. If you want all of the downloads and sort of like knowing the supply list and all that jazz, you can find us on Patreon. We are pay what you can. So like $1 and you've got it all going. That's sort of like your commitment fee of like, I'm going to do this. And what else? What am I missing? I don't know if I'm missing anything. Oh, tomorrow. Let's talk about tomorrow real fast. We're going to make paper circuits.
Yay.
So tomorrow you'll need a printout that I'll put up there for you, some copper tape. If you haven't gotten your Amazon, I know Amazon is a little tricky right now, but you are still allowed to go outside. So if you're still allowed to go out and you haven't gotten it from Amazon, you can find copper tape a lot of times in like the hardware store for gardening. LEDs, not sure where we would find LEDs if you haven't gotten them from Amazon or from me. If you're on Bainbridge, I can get those to you if you come pick them up from me. And then you'll need CR2032 batteries, which you can get at your grocery store. So that's what you would need for tomorrow's project. Other than that, we will switch on over to Zoom. So I'm super excited to see you there. We'll work on Tinkercad and we will also check out the last little bits of this project. Sound good? Awesome. We will see you guys either in Zoom or tomorrow. Have a great afternoon. Thanks for joining us so much.
Mama, that's all the clean ones.
Ooh, they're so clean. This one didn't get very clean, but maybe if we rub it. Oh yeah, so look. Rub some of that off.
Can you
got a lot cleaner. There's just so much on it. It's such a thick.
Mom, I want to use
thick
this
layer.
one. I haven't.
So we have a question about
Last question. Yeah. Go
what
for
is
it.
the process called when you take the copper off the nails?
When we take it off of the nails, or when we take it off of the copper.
See?
So we're plating it onto the nails.
Okay.
And then when we take it off of the copper, I think that's a reduction process. I'm trying to remember my chemistry from a long time ago. Oxidation is when you get more positive. The oxygen is getting more positive, so it should be an oxidative thing. And we have a weird circle loop right now. Yeah. So there's not really a term for taking it off the nail because we're not taking it off the nail. We are taking it off the pennies through in, I believe, it's an oxidative reaction overall. I just don't know which side is oxidated, if it's the copper or the oxygen that's becoming oxidated. Well, this one's all done. Are you ready to take your nail out? We can take your nail out. Let's take your nail out. And then you'll put it right here and you'll wait.
What's happening to the nail?
Well, we put copper in the solution by cleaning our pennies, so the nail is going to get copperified. And you can do that whenever you want to, too. I'm curious.
So you can tell people we're keeping people on mute until.
Oh, okay. We are keeping people on mute right now until people come in. Ooh, and then we're going to figure out a new way so we're not sort of overwhelmed by everybody chatting. I think there is a raise your hand feature if you want to ask a question, and then we can unmute you and like make your screen big. And then that way we're not like, oh my God, what's going on? And Isabella's reaction is really interesting. I'm really curious because she has the penny and the nail in there right now. I'm curious if the copper is going to go on the nail and the iron is going to go on the penny. I'm curious if she's going to get a steel penny out of this.
Steel penny?
Steel is iron, and the iron is getting chomped away from the nail. So we have negative in there too. I'm kind of curious. Like hers is really bubbling. So I'm kind of excited about that project. We'll find out. All right, so let's see. Can we bring them closer so I can actually, it loses our table, but then I can see if we can figure out how to raise hands and stuff so that people can talk. Oh, hi, Noah. How are you? All right, let's see.
Turn me into the.
I'm turning you into something?
Yeah.
The person in charge, too.
Okay. Hello, Lila. How are you today? All right, so let's see how we can figure out how to raise our hands, because I don't know how to do that either. Let's see. Do we know how to do that?
My owl is hot.
If you click on me, you can make me the.
I did.
And then what?
I made you the host. Sorry, we are working on figuring out how we can there is a hand raising feature in here. And I'm just not sure how. I know, George is like, because we're all on mute, except for me. All right, let's see.
Oh, wait, next to okay, I can see the hands.
You can see hands? We have hands?
Yeah, if you go to the participants.
Yeah.
All right.
Obviously.
So if you go down to the participants, you can raise your hand. I'm going to try raising my hand. Let's see.
Yes.
Ooh.
All right,
Then you click it.
all right.
I got that.
There you go.
George he raised his hand.
He raised his hand.
Good
Wait,
job,
can
George.
I also do that?
Oh, now you're muted, George.
Lila, go ahead.
So I was wondering, so my vinegar has this kind of bubbly, salty film on the top. Is there a reason for that, or is it just
Bubbly, salty film. Isabella's is bubbling too.
Mine is not.
I'm guessing we're bubbling because we added more salt than maybe we had planned on, which is totally fine because the salt's going to chip away more. Trying to remember what the actual reaction is, but I think there is carbon dioxide that's going to be made. So those bubbles that you see are probably carbon dioxide getting made is my guess.
okay?
That's my guess. I'm guessing on that. Mainly because when you